So, another example of a between group single factor design that you will frequently see is very similar to the studies that we examined, except they've added a covariant. Let's talk about what a covariant is. And a covariant can be added to a between group study or a repeated measure study. And basically, the covariant is going to help control for some other factor that you think could affect the data and the performance of the subjects in a particular study. So a between group single factors design with covariant is very similar to the studies we just looked at. In a between group single factor design, the subjects that are used are randomly assigned typically to a treatment group, or they're already in these treatment groups if they are something like sporting position. But subjects will be randomly assigned to groups, possibly counterbalanced and so on, just like the studies we've talked about already. One factor is studied. That's what makes this a single factor design, right? So one factor is studied, and that factor has to have 3 or more levels. What's different when we add in this covariant is that we've found, or we think there could be a variable that we could affect our data, but we want to control for because you think it's going to affect the performance on a target variable. Often, the things that we see that we want to control for could be things related to physical maturation, which could be age, right? Again, we could see differences in performance in athletes because of their age. Maybe because you're comparing young, healthy individuals to elderly, and age has played a part. Or we might be comparing youth sport athletes as they move through various levels of performance, and we want to control for that factor. Another thing that can be different is the person's size, right? If I want to see who's stronger, and I have a whole bunch of people, and some of them are really big and some of them are really small, it's not really fair, right? The big people are going to be able to lift more in general just because they have more muscle mass than the smaller people. But the smaller people, if they lift the same amount of weight as all the big people, they're actually stronger, right? Because they are smaller people. So we may want to control for body weight, which is often a common covariant in studies that we see. So when you are doing or reading a study where they're comparing groups in terms of maybe their performance following a training program, but they want to control for something like age or weight and so on, what they'll run instead of an ANOVA is an ANCOVA, which is an analysis of covariance. It's the same test, but what it does is it controls for a factor. So anyway, let's take a look at an example of this that I think hits home pretty well. So this study is titled Physical Performance of Brazilian Rugby Players from Different Age Categories and Competitive Levels. So what this study wanted to do was look at a number of different measures of performance. I just listed 2 of them here. What we can see is a squat jump in this side of the figure, okay, and we can see a counter movement jump here and the performance, and then over here we can see the distances covered in an agility test called the yo-yo endurance test, okay, which again is an endurance test that helps to kind of also involve some sprinting. So these are physical performance tests in Brazilian rugby players. And what they wanted to do was compare and kind of create a set of norms for individuals in this various skill levels. So they were worried that obviously not only the differences in training and how hard they work exist between the different age groups, but they were worried about physical maturation. Specifically, they were worried about the size of the athletes as they move through these different levels, because they did see that these national level players, which are way over on the right-hand side of these charts, when compared to the under 15 players, were just generally bigger. So they wanted to control for the person's weight. And then they ran these tests. So they ran an ANCOVA and looked for differences, even though we controlled for the changes in their size. And this is what was found, obviously, was we still, even when we control for the increased body mass, we saw significant differences in the national level players when we compared them to other groups. We also found, but we found no difference. So we found that in this case, in the distances covered for the yo-yo test, the national players were different from all the other groups. So they were significantly better than all the other groups. They also found that the under 15 kids were significantly different from all the other groups. However, they found no difference between the U7s, the U19s, the professional players on this particular test. So again, they found kind of an interesting finding there. They found very similar findings in the other tests as well. They found that the squat jump and the counter movement jump, we primarily saw that the national level players were very different from everybody else, so they seemed to be very elite, and the under 15 players were very different from the other groups as well, probably because of physical maturation, maybe not as much training time, not as much experience playing the sports, and so on. So anyway, this is an example of a between group single factor design, but where they controlled for a variable. In this case, they controlled for body weight.